Assalamu alaikum. My name is Muhammad Enamul Haq, and I am from Chittagong University of Engineering and Technology, Bangladesh. My paper title is Human Speech Emotion Recognition Using Artificial Neural Network Techniques, and my paper ID is 85. These are the presentation outlined. I will be discussing in this presentation. Introduction. As you know, speech is preferred as the means of communication among human and also between human and machine. That is known as human-computer interactions. Speech emotion recognition can be defined as classifier of methodologies which process and simultaneously classify speech signals to detect emotion embedded in them. It's nothing but a kind of pattern recognition systems. It mainly consists of feature extractions classification processes, and it will ascertain feature extractions and feature selection, classification, and recognition of the emotional output. As you know, as you see the flow of the SR system in this screen. First, taking the speech input and feed to the classification. Feed to the it will take feature extraction, and after the feature extraction, it will be taken to the classified to the classifications, and the last it was recognize emotion out. Aim and objectives. The main aim and objectives of our research, as shown on the screens, are to propose a model for the recognition speech to identify the type of emotion from the speech as neutral, calm, happy, sad, angry, fearful, disgust, and surprised. And the objectives to developing models to recognize different emotion from species and also recognize species using the levers and SQL libraries from the data set. As a literature review, uh, on the previous studies of our literature reviews are showing this slide, and there are main key highlighting this point were extractions and using the data set and the accuracy also considered on this paper. As a methodology, I use this proposed framework of human speech emotion recognition systems. As you see in the screens, we first taken input as speech, then it process as a speech segment, and then it feed to the feature instructions. After selection the features, it take to the training and testings of this model for classifications. Decision to classify. We decided a different class of emotions as shown in the figures. The methodology, database, and input space. Our database was Ransom audio visual database for emotion, speech, and songs. We use this evaluation process of this proposed systems. We're using only the speech dataset, speech and the corpus of the emotion in this native language, and 8 different emotions have been taken to this considered on this paper, which are neurals, clowns, happy, sad, angry, fearful, disgust, and surprise. The total utterance used in this paper are shown in this table. As the methodology part of the feature extractions of our models in this purpose is a systems. We taken as input speech and it goes to the processings, the segment of the species. After processing step is done, it forwarded to the feature extraction of framing and winding space. The framing and winding steps, it will take some speech samples with a small framing and the length of within the range of 20 to 40 milliseconds. Winding step is meant to the windrow after individual frame to the calculating feature extraction process. After framing and windings, it will take into this fast Fourier transformations to convert those signals samples to time domains. into frequency domains. So after FFT, fast phase transformations, it will feed into the male filter bank and frequency warping. It was sending the frequency signals into the male scales. After adding log, it will calculate the discrete cosine transformations. It is the time domains. The result is called male frequency substance coefficients, MFCCs, in this whole processes in this diagram, this section. Methodology and of MLP classification of our models. As you shown, the NN network architectures of arrangement of the perceptrons. Here, the connection of this all input and the first. We are in this perceptor models. We have three phases as shown in this figure 4. This is first one is weightings, and the second one is summations. And after summations, it was taken for the transform stage. The figure 5 was described as the perceptor models as the step of model is first A, and B was the described as the simplified models. Result and discussions. These are the result obtained using MFCC and male spectrograms using the classification of MLP classification of artificial neural network techniques. All the extraction features from the speech and observation of 8 different emotions are given, as shown in the figure tables. Uh, uh, tables. Here you show that the 8 different kind of emotion was taken, and the 8 individuals results recognition rate was accuracy was shown in this side here. It's as a result of all abilities, we reduce the class emotions. Its performance high. This is the confusion matrix obtained based 8 class of emotion recognitions. The percentage of accuracy is 53.89. Now is a ROC curve of this MLP models. As we see the picture, the curve of the MLP models, the generation of individual 8 different class performance is observed according to the NN trains ROC curve, with the area under of the value of the accuracy ranging from 0 to 1. There now the comparison of the previous ACI studies. We have observation of the purpose work with the state of art ACI studies. Um, in this view of 8 different class of human speech emotional accuracy, and also compared with the single and combined data set of this purpose systems with corpus systems. Here we mainly focus on 8 class of emotions and accuracy. Conclusion and future works. In this paper, NN is trained to database contain the Raptors database, and the feature extraction has been used MFCC and male spectrograms. The comparison detailed the proposed models with a 53.89% recursion rate. The paper outcome would assess the information of the pragmatic emotion space recognitions, implementation driven by a wiser selection of underlying feature extraction techniques. And in futures, we obtain recognition accuracy can be improved by the fusion using different structures. Also classify pattern classifiers, the wide range of accuracy characteristics, uh, and also consider the classify if the fusion method in individuals using these ACR systems for evaluations, and and also consider the features and facial expression in these emotional states, as we see them this possible by the brain computer interface, personal medicine, and smart cities projects. It will be updated in the futures. Has a reference of our paper and show. Is there any comment and suggestion and queries of my presentations, you can ask. Thanks for your attention.